All right, so picking up here in part 2 of topographic maps, hopefully you had got the correct answer here. Contour lines that are close together represent steep slopes. Yes, they could be hills, they could be valleys, but if the contour lines are close together, that indicates a steeper slope. Let's see. So we see that here in this picture where the contour lines are packed closer together. We have a steeper slope, and where they are farther apart, there is a more shallow slope. All right, so we see that here, and here also note that they are fairly uniform, and so a constant slope. The distance between each of the contour lines is pretty equal interval, indicating a constant slope, whether it's a steep slope on the right or a more gentle slope on the left. For the next worksheet that you're going to be doing, you need to calculate gradient, and so that's simply just another term for slope. And so we have the change in elevation over the change in horizontal distance. Right, and so the steeper slope versus the more gentle slope. So we'll calculate that. That is a little bit different than relief, which we'll talk about in a minute. So relief is simply calculating the difference between the highest elevation point minus the lowest elevation point. So in a simple map here to the right, the highest that we have here would be, we'll just use the 2150 minus the 2050, and so the relief would be 100 feet. So normally those 2 points would be given to you. So if you're looking at a large map and somebody's asking about the relief, technically you would find the highest elevation point and the lowest elevation point. And so normally with something like this, I would want us all to have the same highest and lowest elevation. So if I were to give you a problem about that, I would tell you those elevations, or tell you point A would be, for example, on one of these lines, and point B would be on the other contour line, so you would have the exact elevation. All right, and so in the investigation manual, page 57 and 58, there's a worksheet that walks you through a couple of these things, including relief and also doing another cross-section. So to do that, you will need a separate sheet of paper, but hopefully if you watch the video in the previous one, describes how to do that. All right, so some questions just for you to think about, the relationships between mountains and valleys, and the contour lines that are close together versus very far apart, how we can locate the location of streams, and so looking for those V-shaped channels in our topographic lines, or our contour lines. I just wanted to take a quick aside because we will be looking at weather soon, and topographic maps are very similar to weather maps, and that what we'll be doing with weather maps, right, is that you can connect all the points of the same temperature to make a sort of a contour line, but with temperature called an isotherm. It connects all the areas of equal temperatures. And sometimes you see that on maps like this of the different temperatures across the United States. But we'll be drawing something that looks a little bit similar to this. So the idea of topographic maps, I like to put ahead of doing weather, because when it comes to drawing these isotherms, hopefully they're a little bit easier to think about after doing contour lines. All right, so this is again just showing the difference in the contour interval, whether we have a smaller contour interval or a larger contour interval. A little bit more lines, and so sometimes more detail is needed. Just consider that as you're making topographic maps. If there's not enough detail there that you really get a sense of what's going on, you can change the contour interval and add some more. All right, so the last sort of culminating activity is another one that's in the investigation manual. It's on page 59 and 60. Just read the directions very carefully. There's some limitations to what you can and can't do in the bulleted items on the top of page 59. So give that a shot, just to maybe clear up a couple of questions that sometimes come up. I'm trying to think through as I look at it here. For each day, you've got a set distance you can go. If you look at that table on the page 59, So you'll have multiple legs. So what that means is you might go straight for a number of feet. That's one leg, and you might turn, let's say, 45 degrees to the east. That's a second leg. Maybe you'll do that for 50 feet, and so on. So each of those times that you turn could be a separate leg distance, and you don't have to use all four. There's just four listed there as you fill it in. So I would make the map on the back. I would do that in pencil and then go back in and fill in that table afterwards. Is probably the best way to go about that. All right. So in terms of what I would like you to know, I'd like you to be able to read a topographic map. And so this is a mountain bike race that I used to do back in the day. They don't have this race anymore up at Susquehanna State Park. And the outline of the race is in orange. And so I would like you to think in this particular race, the direction was counterclockwise. So I'd like you to think if you followed this orange that you would be able to tell what kind of features were coming up, where the hills would be, where the maybe places that you'd recover, where there's not much elevation change, where there's downhills, those kinds of things, where there might be a stream crossing. If you could follow that around and really just kind of read the topographic map. After all, why do all this if you can't read a topographic map afterwards? So imagine you were riding your bike or walking along this path. I would like you to be able to identify where those different areas are. And same here, this is mainly just for practice here, but if you click on this link, it zooms in on an area where I've done some backpacking on the Laurel Highlands Hiking Trail. You can do the same thing. That trail is mapped out on the map there. It's a rather long trail. I think it's 60 or 70 miles long. You just pick a spot there and follow it for a little bit and see if you could accurately read the topographic map. All right, so that's going to do it for part 2 of topographic maps. I'll post this up and let me know if you have any questions.